we refer to this experiment as the blue bottle experiment, and I think this works best when you present it as a problem to a group of students. So I've prepared this using glucose, sodium hydroxide and methylene blue solution. The important thing to note is when you're adding the sodium hydroxide, you always add it to an excess of water and not the other way around. You add your sodium hydroxide to water, not water to sodium hydroxide. So when I shake this, swirl it, you can see we're getting a colour change. So you present this problem to your class. What has caused this colour change? What have I done? And you'll get a lot of different theories. They often say the shaking has given energy and that's what's after doing the colour change. And eventually we'll get to the point where we look at what's in this closed system. And in this we have the solution and we have air. So what's in air that could possibly react in this solution to give us this lovely colour change? So what we have is, we have glucose in a concentrated solution of sodium hydroxide and methylene blue. Now methylene blue is an indicator and it is colourless in a reducing agent, and it is blue when it's oxidised, in its oxidised state. So we have the glucose is in the reducing agent, and the glucose is being oxidised to gluconic acid as we shake it and bring oxygen from the air in here into the mixture, causing our colour change. And then as the oxygen comes back out of solution, it reduces back to the colourless form. So as I mentioned, the safety considerations to be taken into account with this experiment is primarily to do with the sodium hydroxide. Ensure that you're wearing your appropriate safety equipment and your gloves when you're handling it, and that you always add it to an excess of water, not the other way around.